In the vast darkness of space, humanity has always searched for meaning, for origins, and for understanding. With the launch of the James Webb Space Telescope, that search has reached a stunning new level. JWST is not just a marvel of engineering. It is a time machine, peering deeper into the past than any telescope before it. Since its launch, it has captured the imagination of the entire planet. But beyond the beauty of its images lies something even more astonishing: discoveries that challenge what we thought we knew about the universe itself. Costing a staggering $10.1 billion and taking decades to develop, the James Webb Space Telescope is the most advanced infrared telescope ever created. Its mission: to uncover the deepest secrets of the cosmos, from the birth of stars to the formation of galaxies, and perhaps even the origins of time itself. On July 12, 2022, humanity got its first glimpse of what JWST could truly do. The images were breathtaking: the cosmic cliffs of the Carina Nebula, the strange exoplanet WASP 96b, the haunting beauty of the South Ring Nebula, the galactic ballet of Stephan's quintet, and the mind-expanding deep-field image, revealing galaxies from the dawn of time. These were not just pretty pictures. They were data, groundbreaking, revolutionary data that sent shockwaves through the scientific world. For the first time, we were seeing the universe not as it is, but as it was billions of years ago. But among the praise and celebration, something unexpected began to unfold. Some of the images and measurements from JWST didn't fit with our most accepted scientific theory, the Big Bang. To understand the magnitude of this, we need to revisit what the Big Bang theory actually tells us. According to this model, the universe began around 13.8 billion years ago from an extremely hot, dense point known as a singularity. Time and space as we know them emerged in a rapid expansion. Not an explosion in one place, but an expansion of everything everywhere all at once. Over time, this expansion cooled, forming matter, galaxies, stars, and eventually us. A major piece of evidence for this theory is the cosmic microwave background radiation, or CMB, the faint afterglow of the Big Bang. It was detected by satellites like COBE, WMAP, and Planck, and it told us that the early universe was smooth, with tiny fluctuations that eventually gave rise to galaxies. JWST was designed to look farther back in time than any previous telescope, to witness the earliest moments after this great expansion, to find the first stars and galaxies. And it succeeded. But it also revealed something strange. Many of the galaxies it observed were not the chaotic, newly forming structure scientists expected to find. Instead, they were smooth, organized, and surprisingly mature. Even more shocking was their size. According to our models, objects from that far back should appear stretched and enlarged due to the universe's expansion. But the galaxies JWST spotted appeared similar in size to nearby ones. This poses a serious question: are we wrong about how the universe is expanding? And the redshift data added more fuel to the fire. Redshift is a key indicator of how fast objects are moving away from us. The greater the redshift, the farther and older the object. Hubble had found galaxies with redshifts of around 5, which made sense. But JWST detected galaxies with redshifts of 10, 12, and even higher, far beyond what current models predict. If true, this means either the universe expanded faster and earlier than we thought, or something else entirely is going on. Some scientists, like Alison Kirkpatrick of the University of Kansas, have publicly voiced concerns. Others, like physicist Eric Lerner and astronomer Ricardo Scarpa, argue that the data directly contradicts the Big Bang theory. They point out that many galaxies appear too smooth and structured to have formed through violent collisions and mergers. The theory says galaxies grew through chaos. JWST is showing us order: too early, too fast, and in too many places. But it doesn't stop there. Some of the stars observed by JWST and other instruments seem to be older than the universe itself, at least according to the Big Bang timeline. One particularly mysterious cluster, known as HB1, located about 21,500 light-years from Earth in the Milky Way's central bulge, contains stars estimated to be 12.8 billion years old. That would make them among the oldest known stars in the universe. Studied using the Gemini South Telescope and Hubble, this cluster offers a fossil-like glimpse into a time we barely understand. But if these stars truly formed before the Big Bang, or too soon after for current models to explain, it means our timeline might be flawed. And if the timeline is wrong, what else might be? The implications are enormous. If the JWST's discoveries continue to show mature galaxies and ancient stars where we shouldn't find them, we may need to rethink how the universe began, or if it began at all in the way we imagine. Some researchers now suggest alternative models, cyclic universes, quantum bounce theories, or even unknown physics that we haven't yet imagined. What if the Big Bang wasn't the beginning, but just one chapter in a larger, infinite story? Of course, not everyone agrees. Most cosmologists still support the Big Bang model, arguing that while JWST's findings are unexpected, they don't yet overthrow the theory. They suggest that the data might require adjustments to current models. Perhaps galaxies formed faster than expected, or dark matter and dark energy played a larger role in early cosmic structure. These are valid points, and science thrives on challenges. But the fact remains, JWST has shaken the foundations of what we thought was settled science. And this is just the beginning. The James Webb Space Telescope is expected to operate for at least a decade, constantly feeding us new data, revealing new mysteries, and challenging old assumptions. It is ushering in a new golden age of astronomy, one where every discovery opens 100 new questions. It is a mirror pointed not just at the stars, but at our understanding of reality itself. So what comes next? Will the Big Bang Theory survive the JWST era? Will we rewrite our textbooks, our models, and our understanding of existence? Or will we find new evidence that strengthens the theory in unexpected ways? One thing is certain. We are living through one of the most exciting periods in the history of science. With every image the JWST sends back, we are not just looking at galaxies and stars, we are staring into the unknown, into the origin of everything, into the heart of the mystery that is the universe. Thank you so much for watching this video. If you're as fascinated by space, science, and the secrets of the cosmos as we are, make sure to like this video and subscribe to our channel. You'll be supporting future content that explores the frontiers of knowledge. Stay curious, and we'll see you again soon.